Hey, hello everybody, and welcome to this special SANS live stream on multi-cloud security. I guess we need to do a quick introduction here, just by way of introduction. My name is Frank Kim. I've been teaching with SANS for quite a long time, over 15 years now. I've been writing and teaching various courses, currently lead our CISO leadership curriculum and our cloud security curriculum, of which this conversation is a part. And here with me today, we've got Brandon Evans. And Brandon is a cloud security engineer, cloud security expert, instructor, and author of one of our most popular cloud classes, SANS Sec 510 Public Cloud Security for AWS, Azure, and GCP. Brandon, hey, thanks a lot for joining me today.
Most certainly happy to be here.
Great. Hey, how you doing? And hey, anything that you might want to add to that introduction before we just dive right into the various topics that we're going to discuss?
I'm just really excited to talk about multi-cloud. That course is all about multi-cloud, 33%, 33%, 33%, AWS, Azure, and GCP. I would love to answer the question that's the title of the session like right away, because it's such a interesting topic, whether or not multi-cloud's a good idea or if it's inevitable, or I'm really excited to talk about it.
Well, all right. Excellent. We will get there soon enough. I see we've got people joining from all over the world, various places in the US, North America. I see somebody from Ethiopia. So thank you very much for joining on that later time over there. Welcome, everybody. Now, before we dive straight into multi-cloud, let's maybe do a very quick recap. It was just last month, Brandon, when we were together for the first ever SANS Cloud Security Exchange, where we had security leaders from Microsoft Azure, Google Cloud, along with other independent SANS cloud security professionals like yourself, talking about various topics. And maybe this is a little bit of a pop quiz here, but after I heard all of the talks throughout that entire day session, there were two themes that really stood out to me. And what stood out to you, Brandon, in terms of those themes?
I think that one of those themes was that we are all still learning in this space. There's a whole lot to understand regarding multi-cloud and multi-cloud security. And as per usual, security is 5 years behind development. That's definitely one of them. I think another one was in our panel discussion, there was a conversation about directed to me about how I would consult a company who's looking to go multi-cloud. How would I tell them to go multi-cloud? What would I tell them to convince them to go multi-cloud? And I think the conversation was really flipped on its head, because at the end of the day, all of the panelists said, actually, multi-cloud is not necessarily something that security wants to embrace. It's kind of something that we have to deal with, but not necessarily encourage. So I thought that that was really interesting. But I'm sure that you have two other points to mention.
Well, no, we are definitely aligned. Multi-cloud was one of the big overarching themes of the event. The other one was, of course, identity. As so many speakers talked about identity, so many attendees asked questions about identity. In fact, I've had people say, Frank, when are you going to have a class just dedicated to identity? Now, all of our cloud classes talk about IAM to varying levels of degree for extended periods of time, but certainly it's a complex enough topic where you can have an entire week's coverage of just that. But before we talk about that, let's go back to multi-cloud here. And well, I guess first, let's start off with a definition. You just mentioned security teams might not want multi-cloud. Now, it is not our decision actually to go multi-cloud or not. Organizations, by and large, by choice or by chance, are multi-cloud because of different technical reasons, business reasons, by geography, via acquisition, and so on. But Brandon, how would you define multi-cloud given the state of the industry, where it is today and where it might be going in the future?
I think people have used a variety of different terms and a variety of different definitions here. There's multi-cloud, there's polycloud. People call a lot of things varying. They use varying different terms to describe this phenomenon. But in Sec 510, when we talk about the multi-cloud movement, I mainly talk about the trend of organizations using multiple cloud providers for a variety of different reasons. Some individuals will use multiple cloud providers because they have different applications on different clouds, either through mergers and acquisitions or for another reason. Or maybe they're going to purposefully spread out their workloads across those three providers or other providers. And then the third one is that people actually try to run the same application on all three cloud providers. And I really don't like that last one for reasons I think that we're going to talk about during this session. But I think the trend is very clear that we have organizations moving towards using multiple public and private cloud providers. We cite a survey from Forrester, I believe, that says that 70-something% of organizations identify as multi-cloud, meaning using multiple public and private cloud providers. And we also have another chart that shows the percentage of utilization for all the cloud providers. And if you add up all the percentages of organizations using AWS, using Azure, using GCP, that number is way more than 100% because organizations are using multiple providers.
If I can repeat back what I think I heard you say is I really like how you broke it up into 3 different stages or 3 different buckets. Is number 1 is organizations are just happen to be using multiple cloud providers, like everybody uses both Windows and Linux, for example, various operating systems. But then stage number 2 is, hey, your organizations are choosing to put specific workloads in different clouds. So I've seen organizations have different use cases. Let me turn it back to you and ask, well, what specific use cases have you seen that in that stage 2 there, that stage 2 bucket of, oh, well, we're going to put this particular functionality in this cloud and this other functionality in this other cloud?
I think one of the biggest draws is that the different cloud providers do have some unique services. So we talk about on day 5 how there are just some services that are unique. One great example of this is Google's Firebase offering. There's nothing like Firebase in any other environment. There is an open source project that's trying to be like Firebase, but that's it. Now, I don't like Firebase. I really hate Firebase security. And I wrote a white paper on this that you can check out on the SANS reading room called Firebase, Google Cloud's Evil Twin. But a lot of developers like to use it for development purposes. And I like it from that perspective. I just hate it from a security perspective. So by definition, if you want to use Firebase in AWS, you have to set up a Google account either for a Firebase project or a Firebase project integrated with Google Cloud. AWS similarly has some unique offerings. One of them is, I think it's AWS AppSync, which is a managed GraphQL service. And I don't think the other providers have something like that. So if you're heavily into GraphQL, you might want to use that. And Azure has Logic Apps, which is the most unique service that I'm aware of that Azure has. So that's one use case, is that individuals may want to use services from different providers because there is no analogous service or there's no comparable in terms of quality service. Another reason that people do this is for disaster recovery, business continuity. The idea that we can fail over from one cloud provider to another if something goes wrong. Now, I think a lot of people jump to that a little bit prematurely because a lot of organizations aren't even multi-region within the same cloud account. And with all the outages we've seen with AWS recently, they're all US East 1. If organizations diversified simply regions, they would be able to avoid those disasters. And those are the 2 main ones that I think come to mind.
Yeah, great summary. I like how you highlighted that they might move to a specific cloud or leverage a specific cloud for certain technologies, services, the strengths of the cloud providers. I think maybe we all have a sense and we hear that Google is stronger from a machine learning perspective. And in fact, just a little anecdote here. I've got a friend, this is not a security specific example, but he's actually the founder of a company that analyzes satellite imagery for looking for natural hazards, risks of natural hazards, and so on. And they used to have all of their workloads in AWS, and they found that, well, everything was working, but the cost was pretty expensive, pretty high. And they said, oh, well, let's go try the same functionality out on Google Cloud. And it was apparently orders of magnitude cheaper. So there are definitely other business drivers, cost and functionality being primary among them. Now, before we get into the details of that third bucket of purposely trying to architect your systems to be multi-cloud, you just mentioned the current state of affairs in the industry is, look, we even have a hard time being multi-region and maybe sometimes even multi-availability zone, sadly, strangely enough. And before we get to that third bucket here in terms of that evolution, maybe we can take a look back in terms of a little bit about the history of technology. And in my time, working in the industry, there's always been a quest by architects and engineers, this quest for interoperability, if you will. And there's part of this is having different systems be able to talk to each other. So there's been things like Corba, RMI, remote method invocation, and trying to get different technology stacks to talk to other different technology stacks. It just makes sense. But it wasn't until REST actually came along, in my opinion, that this was finally achieved in some more seamless, easy to implement manner. Similarly, we heard always about polyglot programming, development teams being able to choose their different languages. And years ago, when Java was first created, this whole write once, run anywhere idea that the underlying operating system didn't really matter. Now, in fact, it kind of did, but that was the promise of Java. But it wasn't until Docker came along, right, that we've really had true portability in terms of dropping a Docker container into one environment or another. So now we're at a point where maybe the language and the platform don't so much matter, other than the fact that we as security teams need to be familiar with multiple technologies to review them and secure them. And with that as kind of background, what do you think is with the shift to cloud, where is the lock-in, right? It's with the cloud service providers themselves, but what do you think the abstraction layer for the cloud might be that would allow some of this interoperability, make it a little bit easier to architect for purposely multiple cloud providers, like Docker has helped us do, like REST has helped us do from an application perspective?
Yeah, I think you're getting to one of the fallacies that I think a lot of upper level management gets into when they're talking about portability within the cloud. Because yes, with Docker, Kubernetes, and all that, you can take the same virtual machines and the same containers and put them in any cloud provider that you want. But you get very few of the benefits of using those cloud providers if you're simply creating an application that just does things in isolation and doesn't talk to other cloud services. So one example is DynamoDB. This is a very popular database that AWS has. If you want to use that database, you're going to have to use the AWS Software Development Kit, or SDK, in order for the application to interact with it. Well, now you want to take that same workload and move it to Azure. Well, how do you connect to the Azure Dynamo database? You don't, because there is no Azure Dynamo database. They have something comparable, but all the API calls that are made from your application, they are not one-to-one at all. And you'd like to think that these providers would want to make them one-to-one to add an abstraction layer on top of that, but then they eliminate lock-in. They kind of want vendor lock-in. They want you to stay in their provider once you've invested in that area. So there's no real incentive to create a single language for all three of these providers. And by language, I don't mean programming language, but I mean different services, making them analogous to one another, making the APIs standard. That doesn't exist, which is part of the reason why in Sec 510, I've recently started calling it like the Rosetta Stone of cloud languages, because we're able to translate concepts from AWS to Azure to GCP, and they are not one-to-one. There are some concepts that you just do not translate whatsoever. So everybody likes the idea of portability. Interoperability is certainly made much easier through REST and through containers, but it's not just as simple to say, hey, we have this AWS application, let's move it to Azure. You have two choices in order to make that a reality. You either have to not take advantage of any of the cloud services, or you have to rewrite your application 3 times to embed with all 3 of those providers' analogous services.
Yeah, and of course, that just doesn't make sense from an engineering time and a business perspective. We've got a comment here that says vendor lock-in is a consideration, but what you're saying is the current state of affairs is vendor lock-in, specifically for the cloud providers, is inevitable at this point. Now, you mentioned kind of that one overarching abstraction layer, and in the 510 class, right off the bat, you've got a bunch of Terraform code, a bunch of infrastructure as code that deploys the equivalent infrastructure to all 3 cloud providers. Well, what do you see as the pros and cons of Terraform? Can that be something like eventually the glue, or are we going to be writing null resources for the rest of our lives?
That's we've avoided using that many null resources in Terraform, but I'm going to put that for another topic about the engineering of the lab environment. But that goes to the same conversation. There was someone who mentioned this during the Cloud Security Exchange event, where they said, "Oh, we can use Terraform to be multi-cloud, to go from one provider to another." But Terraform is just a tool with a language, the HashiCorp language, and you can use that consistent tool to provision all three of your cloud providers. But you still have to rewrite your infrastructure as code for all three of those providers. Because if you want to write some code to spin up a database in all three providers, those databases are not the same. The settings on those databases are not the same. So it's a consistent framework and language, but you can't just say, "Hey, Terraform, spin me up an infrastructure with an API gateway and a VM and a database." No, you got to write 3 sets of Terraform, which is what we had to do for the Sec 510 lab environment. And it was a lot of fun, but it was also a tremendous amount of engineering work to put together. Is it possible to create an abstraction layer on top of that? Theoretically, maybe if we simplify the different services out there, we theoretically could. It would avoid a lot of precision, though. We'd make a lot of mistakes along the way. And honestly, if I was AWS and someone created an abstraction layer on top of all the APIs, I would just break that abstraction layer just to avoid vendor lockout. I would want to keep them in. I'd just be like, "Nah, we're going to a API version 2 now for no particular reason." Good luck rewriting that entire abstraction layer.
So given kind of the complexity that we're faced with, given the various cloud providers, the tools, and the way that the services work, of course, their goal is to sell more services and make more money, and they're not incented to make it interoperable as much as a ivory tower architect might perhaps want it to be. What's your advice for cloud security professionals today? Those of us working day to day on our teams, trying to figure out what's happening in the cloud, securing the cloud. Where do you think they should start, and where do you think they should go?
I think a big part of this is to look at the Center for Internet Security's CIS benchmarks for the big 3 cloud providers. I think they give you a great baseline in terms of simple settings that you can apply to lock down those big 3 cloud providers. I think that's a great start, but you also have to get inventory of your assets in order to apply those controls. And it's not as simple as just saying, "Hey, let's go to the AWS console and look at all the things in there," because you may have multiple AWS accounts or organizations. You may have some shadow cloud accounts in your organization that you have no visibility into. So I guess you'd have to really work with your operations folks and your developers to really see what the reality is today, and then start applying those CIS benchmarks. I think that's a good baseline.
Mm-hmm. Great, good advice. Hey, and for everybody joined in here on the live stream, just want to remind everybody, if you have any questions, feel free to go ahead and add them into the Q&A, into the chat box, into the comments section. Now, earlier we were talking about Brandon, identity. Now, what do you see? We've all heard the term identity is the new perimeter, and we can see how this affects us from an end user perspective in terms of all the SaaS applications that we use. But in terms of the cloud service providers and the infrastructure and platform as a service with AWS, Azure, and GCP, how would you describe the current state of IAM across the 3 providers, the similarities and differences, and any tie-ins, if at all?
As you mentioned, that would be a week-long course, so I'm going to try to keep it as simple as possible. But I'm going to start off with the first thing you mentioned about how IAM is basically replacing, or at least coming before, network controls. Because if you take a network control perspective, it just doesn't make any sense in the cloud providers. Hey, we're going to take our S3 service and take it off of the public internet. Okay, that's a public API. That's a service that everybody uses. You don't have a dedicated virtual machine for your S3 objects. You're sharing that service with all of the other tenants of the cloud. Now, there are some ways to apply network controls in a variety of different places. You certainly
Service endpoints.
Service endpoints. That's a little advanced. I don't want to go too far in there.
Sorry for jumping the gun.
Yeah, no, you're fine. So the more basic kind of network control that you can do is for your virtual machines or your anything that's hosted by a virtual machine, right? That you have that's dedicated for you, or if you have a dedicated container. At that point, you can secure it. So your application server does not need to be on the public internet. Your relational database service, RDS in AWS, that doesn't need to be on the public internet. But you can't take those public service endpoints and protect or put them off of the public internet. But what you can do, which you just alluded to, is you can have a private service endpoint. And this is a dedicated endpoint within your network that you can use to connect to those public services. But that alone is not going to solve your problem because the public endpoint is still there. And that's where IAM once again becomes important, because the way you lock that down now is you add an IAM condition saying that this particular resource in S3 that I own, that can only be accessed if the request is coming from my specific private endpoint. So the service is still on the public internet, but you are making it so that it can only be accessed from your private network. But fundamentally, it's all IAM when it comes to these managed services. It's all determining who can do what on what resources. And in terms of the differences between the big three cloud providers, there are so many, but I'm going to highlight one that I love to talk about in Sec 510. And that is managed policies or built-in roles and role definitions in the big three cloud providers. So AWS has a large library of managed policies. And these are policies that you can take today from them and apply to your users or your infrastructure. One example is the Amazon S3 read-only access policy. And what does that policy do? Well, it's telling the truth. It is a read-only policy. It says, hey, this user or this application can only read things in S3. That may include some metadata, not just being able to get objects, but it doesn't allow you to create objects or delete objects or update them. So that's great. But the big problem is that an IAM policy typically has two clauses, at least: action and resource. And that resource clause for all of these built-in policies is star. And you might be saying, what? That doesn't make any sense. Why would AWS recommend that I open up this access to all of my resources? Well, I'm going to answer that question with another question. How does Amazon know which buckets of yours are private versus which ones are more public? And they have no way of knowing. So if developers or operations folks are just using those policies without looking at them, they're now granting that access to every single S3 bucket within the entire account. Now, in comparison, in Azure and GCP, those requirements are separated. So you have built-in role definitions that enumerate the actions, but then you are required to assign those role definitions to a particular resource scope. And that is so critical. So a lot of people in AWS just avoid answering that entire question altogether. What resource should this be bound to? And I think that that is the cause of a lot of different IAM-related breaches.
A great explanation, Brandon. A number of people have commented that that was such a clear and concise description of how it works. And it's kind of like the age-old trade-off here of kind of convenience or ease of getting something up and running versus hardening it a little bit more in a way that we would ideally want to. So, that's I want to give a little bit of a teaser here because you just reminded me of something. Is later in the year, I think in December, early December, you've got a multi-cloud security survey coming out. These types of things are what we want to try to illuminate in the survey, I think. But yeah, can you give a brief overview of what that survey entails and what you're looking for there?
I would love to. So the survey itself is live. In December, we're going to be doing a debrief of the things that we found from that survey. So please take the opportunity to take that survey today. I believe that there is some kind of raffle that we're doing for people who fill out the survey. So I think Laura is going to probably post that on the LinkedIn. Definitely take that survey today. But we're going to be going over the findings on December 7th of this year. And that's going to be really exciting because we're going to be able to see how different cloud providers are used across these different organizations. There's a lot of questions in the survey, not that many, but it's comprehensive. And one of my favorite ones that we ask is, do you use these services? And they go through it. And then we ask, okay, how comfortable is your security team with those services? And I'm expecting the gap to be tremendous. And that will hopefully illuminate areas in which people need to invest in training or tooling or both in order to lock down those services that we're using all over the place that security simply does not understand. But we also have a lot of other conversations related to what we talked about today, whether or not they got into multiple cloud providers due to mergers and acquisitions or shadow cloud accounts, why they would choose to select a cloud provider for a particular workload. And I'm really very interested to see the answers to both those questions. And my theory is that a lot of people are going to realize that, hey, we ended up multi-cloud and we had not thought about that, the implications for that whatsoever. It just kind of happened.
Related to everything that we've been talking about here, we've got a comment in the chat, and then we got a key word, a buzzword, if you will, which is zero trust or zero trust network access. And zero trust is really just all about assuming breach, assuming an adversary is in your environment already, monitoring and logging everything, and encrypting all communications. I've worked at various places where once you were inside the network, everything was unencrypted and authenticating, authorizing everything. What do you see from a zero trust perspective in terms of the cloud provider offerings, and how are the cloud providers helping organizations move in that direction? You already mentioned some of them in terms of micro-segmentation and service endpoints and so on. But yeah, how would you tie in kind of this zero trust buzzword, which we know is not one product or one service, back to everything we've been talking about?
I think a large part of that is just that the cloud providers kind of force you to assume breach of your network because by default, everything is a public endpoint. But that's just the cloud service layer. There's also probably many concerns in your application layer as well. So you have to make sure that your applications are properly authenticating to each other. And that's no different than on-prem. I think a lot of the problem that organizations get into with cloud security is they assume that being in the cloud buys them all of these security benefits by default. And so much stays the same. Things change, they stay the same. Application security is such a big part of this conversation. You can have a perfectly locked down cloud service and then have an application that spits out millions of records of PII with zero authentication, let alone authorization running within your cloud network. So now, I guess you could say that those things are also connected, because if you have an application that is compromised, that could result in cloud service compromise as well. We saw something similar to that with the Capital One 2019 breach. But yeah, I think the biggest thing is just getting over the idea that network security is going to save us. It can save us in some places, and we certainly can monitor that network traffic. And that can be very useful, but I would focus more of my energy on IAM as well as access to my cloud services. So I would prefer working on IAM versus network controls. Similarly, I'd rather look at CloudTrail logs over flow logs. I think it gives you much more visibility into what's actually happening in these environments.
Yeah, great advice. You mentioned application security and the importance of that. And you've just talked about examples of various cloud security services that allow you to configure those services in a better, more secure way. And assuming we've done all of that, maybe it might be easier, if you will, to harden the infrastructure versus traditional approaches. But as you said, what's the soft underbelly that's remaining? Just because we've hardened our infrastructure doesn't mean that the attackers are necessarily going to go away. So they're turning their attention to, yes, of course, the applications. And earlier, we mentioned the rise of RESTful services, APIs, and microservices. That is the lingua franca of how applications are now communicating with each other. And it's even more important that we as security professionals learn how to identify and secure those. What are you seeing from an API security perspective in terms of what are some best practices there?
Before I get into that, I just have to make a comment about one of the things that you said, which is, let's say that we lock down all of that infrastructure. Let's not say that. That will never happen, and there will always be more infrastructure to lock down. But yes, let's say we've got that into a relatively reasonable place. What do we do regarding our API security? And I think that similarly to movements into the cloud, I think movements from your traditional monolithic MVC applications to API-based applications, I think a lot of people forget that application security is still important. Things change, but a lot of things stay the same. So you can have a front-end application that is, hey, Frank, oh, okay. You're on mute, but I think you were on purpose. Sorry. So you can have a front-end application that looks like it's super secure, but now that you have your front end and your back end separated, well, now you still have to worry about authentication and authorization for the API itself. Front-end level protections do nothing. It just hides the fact that there's a problem. So I've seen some instances in which applications will query all of the data from your database from the API and then just filter the data on the front end based on who's logged in. And obviously that doesn't accomplish anything. So it's really important for us to focus our energy on the API security independently of the front end that uses it or the multiple front ends that use it. And there's a lot of other subtopics here, rate limiting, putting a web application firewall in front of it. There's a lot of other protections, but honestly, I think so many organizations just get the basics wrong regarding authentication and authorization, which is in a way kind of similar to identity and access management, just at the application level instead of the cloud level. People just really need to focus on that, get that basic done, and then we can talk about all these other types of attacks. And we're far from that, unfortunately.
Awesome. Hey, we've got a comment here from John. Oh, hello, John. Nice to see you. It feels like the scope of our Web 2 security landscape continues to grow, while Web 3, which we haven't even talked about, has its own challenges. Now, hey, Web 3, we won't go into all of the details here on this session, but we've got crypto, we've got blockchain, we've got various other slew of technologies in this purported decentralized promise of Web 3.0. Now, what do you think? What about the future of digital identities as you see here in terms of the overall approach? Is there anything related in terms of Web 2 and Web 3, going back to the identity theme here?
Well, I think a lot of folks have a fear of missing out when it comes to Web3 technologies, cryptocurrencies, and blockchain. I'm very much a skeptic about how many actual applications there will be for those technologies. I feel like it is a technology in search of a problem. And eventually we're going to have probably an application of it that makes sense. But I think we're jumping the gun a little bit, even by calling it Web 3, to think that it's going to be as big of a transformation as Web 1 to Web 2. Because from my perspective, and I'm not a cryptocurrency expert at all, but my understanding is that fundamentally, the blockchain is just a database with a lot of different computers in a network.
Very slow database.
A very, 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 very slow database that gets some kind of consensus as a result of having hundreds or thousands or tens of thousands of machines in the network. So the only benefit that I see, and please stop me if I go too much into a rabbit hole here, the really only benefit of this database is that there's some level of verification that it is a legitimate transaction. How many applications of that will really exist? Well, one big use case that folks say is the ability to take their identity or their resources and move them from one platform to another. But we already have that. We already have OAuth 2.0. We already have OpenID Connect. There's a central authority that is the arbiter of that identity. But in the Web3 world, yeah, there's no central authority. But if people don't accept that decentralized authority, what value does that blockchain even have? So I think we're way too early in the evolution of this technology to really know where things are going, or if they will go anywhere at all.
I totally agree with that. And it's funny that you mentioned that in terms of decentralized, which is one of the promises of blockchain. But now in all practical implementations of it, there is a centralized authority like a Coinbase or some other central ledger that you've got to have all of your transactions with. So we're kind of back in the same place for a less performant technology. And yeah, we'll see what that killer use case actually is when and if it comes about. Now, we're getting close to wrapping it up here. So, I want to just say, Brandon, how would you summarize for all of the security professionals listening in that might be early in their cloud security journey, or maybe a little bit further along in their cloud security journey? what do they need to think about in terms of continuing to secure their teams, their organizations, building their security program, and developing their own cloud security skills?
Well, to steal an answer that you've given before, you got to stay curious. You got to really ask questions about what's going on with these technologies. Assume as little as possible. Don't just listen to what other people are saying, because they may also not understand what these cloud technologies actually do. If you think that someone is just glossing over security as a result of using a variety of buzzwords, Kubernetes, Lambda, Zero Trust, all these other things, IaaS, RASP, all that stuff, really dig into those assumptions. And to do that, you need to learn a lot more about these cloud providers. And we obviously have a lot of resources here at the SANS Cloud Security Curriculum. I would definitely recommend going to check out sans.org/cloud, which is the landing page for all of our resources. But I'm going to highlight a couple of those resources, some of which are new that I really think that you'll enjoy. First of all, is we now have a Discord channel that you can join. For those who are not familiar with Discord, that's kind of like Slack, but it's more targeted towards, in my experience, gamers or other like hacking communities. And as a result, we're a security community. It kind of makes sense to be in that kind of space. It also supports the ability to have voice channels where you can pop into a room and talk to people who are interested in talking about a particular topic that day. And this Discord is open to the public, so I'd really recommend checking that out at sansurl.com/cloud-discord, which is also in the footnotes of this presentation that you're looking at right now. And there's also a podcast that is starting at the end of the month that I am hosting, and I am so excited for that podcast to launch on the 28th. It's going to be excellent. We're going to start off with 3 episodes, one of which includes Frank here. We also got Anton Shavakin of Google Cloud, and we have an awesome IAM panel that includes Carl Fossen, Kyler Middleton, and Kat Traxler. It's going to be phenomenal, and then we have many, many episodes coming from there each week. So I really hope that you will check that out. And in addition to that, we also have our cheat sheets, our posters, and our flight plan that shows you the different courses that are going to map to the skills that you want to learn. So there's a lot of materials out there. We provide, in my opinion, the best of those materials, but you got to stay curious. You got to keep learning. That's the only way you're going to be able to secure these things.
Great summary. Hey, just to kind of wrap it up here, we'll say, hey, we're talking about multi-cloud, and multiple clouds are definitely here. Multi-cloud in terms of interoperability, well, not there yet. Hey, stay curious in your journey, as Brandon said. Thanks everybody for taking the time to join. You can find Brandon on Twitter at BrandonMaxEvans. Find myself at FYKim, and connect with us. Feel free to connect with us on LinkedIn, and look forward to seeing you at the next event. Brandon, really appreciate it. Thanks a lot, everybody, for joining.
Most certainly. And I can't wait for next year's Cloud Exchange event. It's going to be hopefully a long tradition of having amazing people talk about these technologies from different organizations.
Right on.